Hi, welcome to this second video in the revision series, and today we're going to have a look at how we can apply the formulas applicable to coordinate transformations. In this end of the second session or the second lecture series, you had two practicals, a practical A and a practical B, and they look more or less like this. There was a point on a spherical Earth with a radius of 6371007.1 meters with the following coordinates: 25, 45, 25 minutes seconds south and 28 degrees 18 minutes 35 seconds east. I want you to calculate the Earth-centered, Earth-fixed coordinates of the point, and once you've done that, the datum shifts in the area is that. Calculate the new graticule coordinates. Now, graticule coordinates, you remember, is latitudes and longitudes. Good. So, how do we go about this? The first thing we need to look at is in the second lecture series. You'll find the slide transformation latitude and longitude to Earth-centered, Earth-fixed in the sphere. And from there you get the formulas. X is r cos phi cos lambda, y is r cos phi sin lambda, and z is r sin phi. And you've got an inverse transformation as there to go back as well. Now, it's probably a bit easier if we go for the ellipsoid straight away. Because although we have a spherical Earth to start off with, we're going to have ellipsoids in the next part, or practical B. So what we have there is we've got the radius of curvature in the meridian, the radius of curvature in the prime vertical, and then you also have the x, y, and z. So you've got x is n cos phi cos lambda, same y is n cos phi sin lambda, and z is 1 minus epsilon squared n sin lambda, or sin phi. You can also use b over v sin phi. So this is most probably the easiest way to start doing these things, because once you've got those, you can convert between spherical Earth and ellipsoidal Earth, and spherical and ellipsoidal Earth, and it just makes things slightly easier. So to look at that, let's set up our Excel template. Firstly, we put a from ellipsoid there. It's going to have an A and a B, and then we can calculate the other formulas. We can calculate the C, we can calculate the F, and epsilon squared. 1 minus epsilon squared, remember from the previous slide that we're going to use that as well, and we might even use the delta. And the same with the two ellipsoid. An A and a B and a C and an F and an epsilon squared, 1 minus epsilon squared and a delta. And then at the bottom here, we can put our coordinates. ID, longitude in degrees and decimals, latitude in degrees and decimals, longitude in the radians, latitude in the radians. Now you can see I've already set up the formula in there. That is, this one is to calculate the radians of B19, which is that one, once there's a coordinate in there. And similarly over there, I've set up the coordinates over there, or the calculation over there. V, I've set up there, is the square root of 1 minus 1 plus B8, which is delta, times the cosine of the latitude. Similarly, we've calculated n as c over v. You've got the c over v over there, and you've got the v over there, because remember, v is dependent on latitude. And you can also calculate the m, which is 1 minus epsilon squared times n, and obviously now you've got 1 minus epsilon squared calculated over there already, so that becomes fairly easy. And from there you can calculate the x, y, and z, and then over there I've had dx, dy, dz, which you can apply over here, and you have a new x, new y, new z, and then you can use the inverse transformation. You go back there, the inverse transformation, that one, to go back to latitude and longitude, or longitude and latitude, and then to degrees and decimals, latitude and longitude. Again, I mean, there it's just easy. You just tell Excel it's degrees of the previous one. You don't need these interim steps, but they're handy. And what I also did is I made a spreadsheet over here, which let's just enlarge this slightly, where I can input degrees, minutes and seconds, and then calculate degrees and decimals. And there I can put degrees, minutes and seconds in, and I can calculate, or degrees and decimals in, and I can calculate degrees, minutes and seconds, which is going to be handy now because we need in our presentation, or in our practical, we've got degrees, minutes and seconds, which we need in degrees and decimals once we go into Excel. Okay, so let's get to it and fill in this lot. Firstly, we need a spherical earth, so we can calculate all these things. You don't need the C and the F and the E and the what's his name in there, because they're all going to be, you're going to recalculate them over here anyway. So all you need to do is copy that and stick it in there, and cancel, copy these two, put them in there, and these will calculate by themselves. And you can see C is the same as the radius, A and B, because A and B are the same for a sphere. F is 0, epsilon squared is 0 because there's no eccentricity, there's no flattening, and obviously 1 minus E remains 1, and delta is also 0 because that's another eccentricity. And we want to go to, again, a spherical ellipsoid, or a spherical earth, so we want to go there, and okay, we copy those and paste them over there, and then over here we'll get exactly the same as at the top. Good. What we also need in here is our dx, dy and dz's, which is minus 195.2, 125.6 and 205.4, which we can paste into the Excel over there, and it's going to look like that. Good. We can do, we don't have to do the others in the meantime. So now we're going to take our latitudes and longitudes, 25, 45, 25 south and 28, 18, 35 east, paste them into my degrees, minutes and seconds too, and you can see that's degrees and decimals, and that's degrees and decimals, which we can copy from here and then input into my datum transformation over here. And there you can find it. Then we just do the radians thing, the radians, and we calculate V, which is the formula from over there. Let's just go up this one, here you can see V squared. So if you go to the PowerPoint over here, or at least the Excel over there, you'll see that I've got the square root over there in my V. And similarly, I can calculate all the others along the line. And let's just highlight them all and make them all black. And you can see I've now been able to calculate my X, Y, and Z. Now to get a new X, all I need to do is take this one and add that one. Similarly, get a new Y, take this one and add that one, and then Z, take this one and add that one. So that's the next columns. Get a new X, new Y, and a new Z. You can see it's just that $1 because you're always going to add that one in this whole column. And then we can calculate the new longitude and the new latitude, which is the A tan, which comes from over there in the presentation. From there, the inverse transformation for ellipsoidal X, Y, and Z, and the same with the other one. So you can calculate those, and then go back to your decimals and degrees, and now you can input those in here, and you can get out, at least you can get, if you input those again in here, you'll get degrees, minutes, and seconds, which you don't need for the datum transformation. Because normally once you've done a datum transformation, you go into some sort of a GIS, and from there you need degrees and decimals anyway. And you can see it's not all that different. Let's put your longitude in there, and put it in degrees, minutes, and seconds. Paste values. There we go. Because there's a formula in the previous one. So just pasted the value, and you can see it's 28 degrees, 18 minutes, 42 seconds now instead of 35 seconds. That's what your translation does. And you can do the same with latitude and longitude, or with the latitude. And then after that, it's easy going, because now you've got your datum transformation set up. All you need to do is, for the next issue, I've got WGS 84 ellipsoid, and I've got a Prac 1880 ellipsoid, and I'm going from Prac 1880, so I copy those and I paste it in there, and lo and behold, it calculates the rest, and then it'll calculate the stuff over here as well. And except I don't want to go to the sphere over here, I want to go to WGS 84, so I'll copy that and I paste it over here, and the rest of your calculations is all done. Good. And notice how I put the things in columns, because it's very easy to draw. If I want to put something else in here now, so I want to put 25 degrees, and I want to put 24 degrees, and I want to put a latitude of 18 degrees, and then all I need to do is take this whole lot draw it down, and you've got everything calculated over there. So, that's how easy it is. And hopefully you won't have too many problems, because this is also the first or the second, the third and the fourth part of task 2 of the assignment. Once you've got the things in these formats, it's very easy to do. Right, go for it. I'll see you in the next video.